So what are you using? OOPS concepts, but still we will cover OOPS concepts as well. But first, let's start uh, so that you can at least, start doing things, start understanding data, and with time we'll cover inheritance and all those things as well. Okay, but let's start with the most important concepts that are, used very widely. Okay, so let's say you have this is your data frame. Let's take a simple one only, 345. This is df1, and then you have df2. Data frame, no, inside data frame you are saying you want to have one set. C, let's take this A and this is B. So as a what? As a value, but usually it is not the best practice to do such thing, because that would be of no use. If you put a data frame inside a data frame, otherwise, and it would be very difficult, and very slow as well for any of the operations that you will do. So usually that is not you know done. Okay, let's import pandas. Yeah, pandas data frame, and let's put it like this. And here let's do again pd.data frame. Oh, sorry. Okay, now we have two data frames, df1 and df2. Fine. Now let's say uh, you want um, to, let's see, df1 first. Df1 is like this. Okay, a and b are the column indexes, 0 1 2 are the row indexes, and these are the values. Now let's say you want to convert rows to columns. Then what will you do? You want this 1 2 3 to be converted like this, 1 2 3. Then you want 3 4 5. So basically 2 rows and 3 columns you want, instead of 2 columns and 3 rows. df1. So simply you can use dot t. Okay, so this is how you can move it to column 2. And similarly this back to this, again you can do dot t. Okay, that would do a transpose. Fine. Okay, very good. Now let's say you want, there are two data frames, df1 and df2. You want to convert these into a single data frame. Okay, so let's say you want to do, so this is known as, like you do string concatenation, similarly you have data frame concatenation also. Now you see 1 2 3 3 4 5, 1 2 3 3 4 5. Achha, I provided the same elements. So you understand. Row index can be same. Row index in this scenario is same. So let's say df3 is this, but when you will do, let's say, df3 dot, now I'll show you why we use ilock and lock. We had used this na, ilock and lock. Sorry, we had used this na. You remember na? Okay. So now you see, now we have concatenated. So this indexes can repeat as well. The row indexes. Fine. Column indexes we usually don't repeat. Okay, that those are unique. And let's say df3 dot ilock. Then what we do? Don't remember the row index and the column index. Okay, you got one. This will, or you could also do like this: 0, comma 2. So you got first two rows and the zeroth column. Okay. Now instead of ilock, if I would have used lock, lock stood for the name of the column and the name of the index. So let's say here it was 0 and here it was A. So now you see there are two zero indexes, this one and this one. For the row index, there are two. So see, both are returned when we use lock. So there can be repeated row indexes as well. Fine. So this is why sometimes we use lock, sometimes we use ilock. Okay, and this is concatenation. So this we have concatenated by appending the rows. Okay, so you see, first we took this data frame df1, and then below this we added df2. Okay, now this is concatenation by rows. We can also concatenate by columns, df1 comma df2, and here you need to provide axis is equal to 1. Now you see what would happen. Now you see this df1 is this, df2 is this. Okay, this is by columns. By default, this axis value is 0. If you don't provide anything, it becomes 0. But if you provide 1, it becomes columns. Fine. This is known as concatenation. Okay, fine. Now let's take some data. We would be having some sample data. Let's take California housing data only. Let's copy this. Okay, let's import this data df cal. Fine. Let's see the head. We see this. These are all the data sets. Okay. Now let's say df cal. Okay. Now you see we have one is the training data. One is what, the test data. Now you see. Now this is df cal. Let's say train. Okay. Df cal train. And this is the df cal test. Df cal test is equal to pd read csv and this, and df cal test dot head. Now you see the columns are same, because this is just test data, this is training data, and if you see the rows, how we see the number of rows of a pandas data frame. Sorry, but columns tells us the column names. I want to see the number of rows, size of the data. How many rows are there? Dot size, like this. How this would work? Dot size. Oh, or you can also use shape. This is better one. Hmm. Dot size tells you the size in MB. Okay, how much MB it is occupying your pandas data frame. Shape tells you rows and columns, and length, LEN, that tells you the number of rows. Okay, so you see this data has 17,000 rows, 9 columns. This data, the test data, has 3,000 rows and 9 columns. For concat, it is necessary that the columns, they are same. Both the data frame are having same number of columns. If you are concatenating by rows, and if you are concatenating by columns, then the rows should be same number of rows. Okay. So now here, let's say if you want to create a DF master, we can do a PD concat, and we can have df cal train, df cal test, and what should be the axis? Rows are different. Yeah, very good. Fine. So now if you see the size of or the shape of master, this should be what? How many? No, rows. First is rows, no? So 9 columns are there. Very good. So 17,000 plus 3,000, it becomes 20,000 rows and 9 columns. This is, you know, where we use pd.concat. Fine. Now let's see some more things. Let's say you have df master, and let's say you have the house median age. Okay, this is your column. Let's see top 10 values. Okay, some floor or integer values. Okay, although it has given d type float, but usually the median age, because it has given, so it can be float as well. Or let's take total rooms. Okay, let's see total rooms. Now whenever you are reading CSV na, it automatically infers the data type. Okay, based on what is there in your CSV file, pandas automatically understands what is the data type. Okay, but if you want to specify the data type, so that is also possible, that for what column I want what data type. If you see this, see, I'll show you. Uh, there should be an example. This is data frame. This is a bit cryptic. Just a search. Just a second. Yeah, D type. This is the argument. D type. Type name or dictionary of column and type. So let's say column was A, so you can provide it as numpy float or numpy int or simply int. Okay, like we used to make our this here na, when we convert into pandas data frame, so we can use this D type is equal to A is what? Let's say our A is int 64. Okay, and B, 64 is simply how many bytes, like in C, C++, you remember na, we used to provide long, short. 64 is one second. Yeah, yeah. Just a second. What it's saying? It is not a total. Just a second. This is fine. Okay, we don't need to. Let me try simply. Input, input. Object of type has no length. PD or data frame. This is your data frame. Okay, this is fine. Then you need to provide your int. We should can provide np.int also. There is also this .d types function that we use. That also I'll show you. Is it d type? Yeah, it is d type only. Just a second. Let me check what all it is allowing. Okay, d type has to be a. Let's use this. We need to close this data frame. Let's import numpy as np needs to np dot int 32 np dot int 32. It's fine. Or we can simply do. Let's simply take this for now. df1 is like this, df2 is this. Then we can do df1 dot as type. And let's provide this. Float 32, let's say. Hmm. You see? So first you just import the data, and then you can also use this as type function, and you can convert your, I'll show you what happens. You can use this dot d types. Okay, this is the property of the df1 dot d types. This is the property where it displays every column and the corresponding data type. Okay, so you see initially it is in 64. You can convert this into float as well, but d types. Now this would get converted to float 32. You see, a is float 32. This is in 32. Fine. Now if we see in our df master dot d types corresponding to every column, we can check the data type. So everything is float. Okay, now let's say we consider this total rooms. Okay, we can also change the data type. We can use pd to numeric. But we can convert this into numeric. So this would automatically infer. So if we want to specify specifically, So we can also do like this, downcast. Integer. Now you see the DF types. You see, so using this pd.toNumeric, and actually we are downcasting. So we are moving from a higher data type which requires more memory to a lower one. So this is why we have to downcast this. Okay, fine. In case required, let's say if you are using some integer and you want to convert it into float, and likewise. There is also another way, df master, I think. Let me check if this is there. Total rooms, but as type float. Let me check. Yeah. So using this also you can convert. So here it can float, integer, int, or anything. So now if you see, this is again back to float. Fine. So these are multiple ways using which you can typecast your pandas columns. Okay, by using pd.tune to numeric. There are many pd.to. This is not auto completing. Otherwise, there are tune numeric. I think to string and all those things. There would be many. To date time. Okay, so we usually many times we use to date time when we want to convert a string to a date time. Okay, so this is done. Now let's say we have this column, and let's say we want to convert this column into an integer. Okay, let's see top 10 values. Okay, these are all integers. Now let's say if you I want, this is now what, a panda series. This single column is a panda series. Now let's say I want to find the mean value, so I can simply use this function. Okay, let's say if I want to sort this. Okay, let's say I want to sort my pandas data frame. So now I'm not sorting just this series, I'm sorting the entire data frame. So I can use sort values, and here the name of the column, total rooms. Now you see what is the output. You see the entire data frame is sorted now according to this total rooms. Okay, so you see it's sorted in ascending order, and every row is preserved. Like if this was the lat long corresponding to this particular house where the total rooms was this much, so everything is preserved here. Okay, so you can even sort. And let's say if you want to sort it, let's say in descending value, so you can just do ascending is equal to false. So now you see this is sorted in opposite. Fine. Now let's say you want to rename any column. So I told you that's also df dot rename. I told you this columns is equal to, and you can just provide a dictionary. Let's say total rooms and the new name, total rooms renamed. Okay, or df master. See, total rooms renamed. Okay, the now you see this original data frame has not changed. Original data frame is same, but this one has changed, which we are seeing. If you want to change the original data frame, then you will have to put it here. You'll have to assign this to the original data frame. Okay, this makes sense. So simply by using rename, So this rename function returns a new data frame with the name, column name, whatever we are changing it to. Similarly, sort values, original data frame is not sorted. This creates a new data frame that is now sorted. And now we can, just if we just want to create, let's say, df master sorted, so this would be a new data frame, or we can simply change the original data frame also. Okay, then there is also this in place is equal to true. Okay, let's see this. Now you see it has returned nothing, and earlier it was returning a data frame. Now you see the master dot head, you see it is sorted. Yeah. So whenever you will see this in any function of with pandas, in place is equal to true, this means that the result has not to be returned in a new data frame, but the original data frame should be changed. This is just like call by value, call by reference. Okay, in place is equal to true, you can say call by reference. Change the original data frame only. And if this is not true, then create a new data frame with whatever we are trying to do. Okay, very good. Let's say if you want to remove any column from this data frame. So how will we do that? We can use df master dot drop, and in this we can provide, let's say, latitude, longitude, okay, and axis is equal to 1. Now you see there are 7 columns. Axis 0 would start checking this row indexes. Okay, if you just do it like this, it will give you an error. This is not found in row. Row indexes are numerical. So this is the issue. If you want to remove any particular row, let's say you want to remove this row, so you can just provide the index of this row and axis equal to 0, so it will remove the row. And this is again creating a new column. If you want to change it to original column, then what will you do? Fine. Just a second. Just okay. So this is done. Now uh, let's say we have, okay, filtering the data set. You are aware, है ना? This we had tried earlier also. Let's say master, df master, and let's say total rooms is greater than 100. This would give you all the rows where the total rooms are greater than 100. Okay, you see the lowest room is this. Fine. Now, one very interesting thing. Let's see. Uh, let us see. Let's say df dot sample. This is another thing. 100. You see what this would our df master. What this would return is, it will return you 100 rows from your data frame by randomly. Okay, this makes sense. many a times, what we need is, we need some random data from, we don't need 20,000 records. We just need, let's say, random 100 rows. So if we will do head, it will just return the top 100 rows. Okay, you see it is sorted. You see this total room is sorted. This means these are top rows. If you take tail, this will again give you last 100 rows. But using sample, this will give you randomly 100 rows. So you see total room, this is now not sorted. So randomly it is giving 100 rows. Fine. Okay. Now, one more thing we can use. You are aware about SQL as such? You have used SQL? Okay. Now see, very nice thing in Pandas. There is this query. Okay, and here you can query your Pandas data frame just like SQL. See, total rooms is greater than 100, and total bedrooms is less than uh, 50. See, got the result. So total rooms should be greater than 100, but bedrooms should be less than 50. So just like SQL query, you can specify, whatever is the column and whatever is the filtering condition. Fine. So this is very, very nice tool to have. You can use like this. Let's say total rooms between 10 and 20. Okay, I think between they are not doing, so we raise that than equal to 2, and total rooms or less than equal to 20. Fine. Like this also you can filter. Yes, yes, that also we'll see. Joins pay we will come. So this filter is done. Nah, so this filter also you can use, but let's see some other data set. This is California housing. This is MNIST. So we need some, uh, text data set. So pandas all, okay, no worries. One second, one second. So pandas also has some uh, inbuilt data sets also. Okay, but let us use. I'm just uh, taking out some data set where we have some text. Honey, I'm not writing anything. Just a second. See, there is this function pd.util.testing.make mixed data frame. This just creates some sample data frame. Okay, this is just any random data frame that this has created. Okay, sorry. This is just a inside PD library. There is this util, file. Inside this util file, there is this, testing class, and inside this testing class, there is this function. Okay, and inside this, if you will, this is returning what? This is just returning some sample data frame. Any random values are there. Okay, just let's say, rather than creating the data frame like this every time, we can simply use this also. Fine. So what we can do is df, and you see c. Let's say we so n unique. There are 5 unique values. df dot let's see shape. Okay, df dot value counts. Let's see it is I think 111 only. Okay, sorry. So I think this data is not enough. I want some more data. So let's say, let me take some data on which I can run some, filtering. Let me create some text data. Okay, here I have. Fine, let's say this is your data. df is equal to pd dot data frame data. Okay, df dot head. Fine. Now let's say we do df dot filter. Okay, and we want to filter. We can also filter on the entire data set also, I think. Let's see, J. If we try, think we need to do it on. No, no, I think we one name. I am trying to do. One second. So here, okay, items is equal to name page. Yeah, so using this we can filter just the rows. Oh, just the columns. Okay. Now, if I want to do like, okay, there is this. You have used like in SQL. Let's try here. X is equal to 0 meaning. Check this on rows. है ना? Okay, so this would check for the row index. This like. Okay, we need to actually set index. I have not taught. Na, I'll teach that afterwards. So let's use a simpler one. Let's say dot items is equal to name line set index name. Ah, and then we do a filter on j like is equal to j, and we can use axis is equal to 0. Yeah, and we can just do like this. Okay, this is like this. Okay, so this even like AI, if I just use like is equal to a, you see now. So you can change the index from, by this default 0 1 2 3 to any column also. Okay, so here I have set the index to name. So if you see this, If I just show you this, what would be the output? You see, this is now the index. Let's say if I do this in place, or if I just do df is equal to this, now the index of df becomes what? What does it become? Index is whatever was the value in this name column. Okay, and if I want to, I can also do this. There is also this function reset index. If I want to reset the index using this, again it will go back to default 0, 1, 2, 3. Okay, so using these two functionalities, we can also reset indexes or set index. And then filter can be used on like this on the index, row index if access is 0, and filter can also be used on, let's say if you have 100 columns, okay, and you want to just take the columns that are having this dd. This would just give you name and the address. The name is coming because this is the index. Okay, let me just reset this also. Now just the address column is coming. So using this filter function, you can filter your row indexes, you can filter your column indexes. Okay, I've also taught you how you can move your column, entire column to the index. Okay, and back to the column both ways using set index and reset index. Okay, now these things I'm telling you now, but now we will work with some data sets in the next class. Then these would be even more clear. Why these functionalities exist. So currently, this would be a bit tough to understand, but when we will actually do this on certain data sets na, then this would become very easy. Okay. Okay, now this we have done. We had also seen the group by function, hai na? This we had seen earlier. Okay, very good. And join now is left. Hai na? Join we will see how to join and how to merge. Those things we will see. Okay, and uh, let's see. This filter is done. Okay, this is done like this. And let's say you want to do df1 and you have df2. Let's say these were the two initial dfs, df1 and df2. Now if you want to join, let's say df1 dot join df2. If you want to do it like this, so yeah, so the column names should be independent. Or what you will do, df1 dot join, I'll show you, pd dot join, there has to be the on. Okay, this is this, simply this join won't work. On is equal to a comma. Let me take some uh, other data set which we can join. Okay, that would make more sense. Let me delete this. Let me also delete this. Let's take this data set. Okay, take this data. Okay, and let's divide this into df1 and df2. Okay, so df1 becomes, let's say, data name and age. Okay, and let's say df2 becomes name and address and qualification. Fine. This is df1. What is this? Okay, this was already not data, this was df. Fine. So df1 becomes what? Name and age, and df2 becomes these three things. Okay, now this is a typical SQL scenario what we try to do. There is a common index or common column, and using this column we try to join. Okay, So same thing. How in SQL, what would you have done? Fine. So here what we do on name. So here we provide the common column on which we want to join. Just like in SQL we do. What is it saying? Merge an object into okay. You're trying to merge an object and in 64 column. Object and in 64 column. This is DF2, no? Yeah, this is fine. Dot B types. So this becomes age is an int 64. Okay, and it's saying that the all these are object columns. So it is saying you can simply use pd.concat also, or I can simply convert this into an object column also. So that is also possible. Okay. So there are two ways to join, or there's also this merge. So let's see merge. That is a bit easier. So here you just provide df1, df2, and on is equal to name. Let's see this. If this works fine, then we will go back to join afterwards. Yeah. Okay. You see this? So using just like the join, it is doing the same thing. Okay. So you can also use merge. Fine. This makes sense. Very good. So join, can be inner, outer, left join, right join, everything that is also possible here. Okay, and similarly, uh, merge also. Okay, but we should also be able to use join, because usually we try to use join. That is a simpler one. Let me try this again. So what I'll do is I'll convert, let's say, df1. I told you that we can convert this to as type object. Okay, df1 age. Fine. So now if we try to do this, on is equal to name, version 64 of this df1. One second. Let's see, df1 dot d types. This is now object. This is the fine. Dot lock. This is now, let's say, all rows, all columns. But let's see this. Dot lock. All rows and this column. This should be fine. Similarly, name is object here also. Name is object there also. df2 maybe we have name. Name should be of object type. This is fine. then this issue should not come ideally because we are using name as the column to merge. We are not using age. So why is this kind of issue coming? Let me see. Here we are taking df and we are forming this. Fine. This is also fine. So here is age, but we are actually joining df1 and df2 using the there are no null values also. If in such scenarios this doesn't work, this join, you can simply use merge. That is one easier scenario. And in merge you can also provide how means left merge, right merge, like you do inner, outer, everything is possible. Like we do an SQL join, similarly this is also possible. Okay, so this is same as your join, but we'll in later classes we'll see join here because I might be creating this data set here only, so might be facing some issue, but ideally it should work fine. So if let's say if I change this to an str object and then try, no, this is you see df1, this should actually be df2, let's say 1. Data likes most transmits. L suffix is equal to left, R suffix is equal to right, R is equal to inner. Hmm. This I'll check why this is not working. Usually this should work fine, but here might be because we are creating some data set, so that's why it's causing some issue. Otherwise, okay. It is actually it joins. I think just a second. Let me set the indexes one. Df dot index name, and then I will not have to provide all this. Set index name. Let's try this. Hmm. You see, now it's working. So for join to work, the you can use uh, your the common column inside the index, then it would work fine. Okay, you see I have moved the this column to index of both the data frames, and then simply I joined. Otherwise it will try to join on you know whatever is the default index. So if I don't set that, then let's see, df1 is this, df2 is this. Let's see this. So here there is some issue with the index, it is saying that it is trying to do. Although here it shows this only, but there was some issue with related to this. But if we just set the indexes, then join usually works fine. Okay, fine. But mostly we use merge works fine. Merge is also same as this. You can provide multiple columns also here, and using join you can use this. You can set the index and then join. So all this is done. I'll also share the notes for this. Okay, I'll share one notes and that should be fine. And otherwise, for this book, so I won't say just read the notes. That should be suffice.